Algebra 1, Common Core, Unit 3, Section 1, Greatest Common Factor. So the notes here explain that factoring is a form of division. And there are many different types of factoring which you're going to learn in this chapter. There's actually 6 sections in this chapter. We do greatest common factoring, we do difference of two squares, trinomials, grouping, factoring completely, something I call AC factoring. So there's a lot of different ways of factoring, but they're all forms of division. And when you factor a polynomial, it factors to a product of factors. Now, what do we mean by factors in general? Like, if we forget about polynomials for a second, if we had something like the number 10, we know we could think of the number 10 as 5 times 2. What this means is that 5 and 2 are factors of 10. They are factors of 10. 5 and 2 are factors of 10 because they are things that multiply to 10. And that's what a factor is. A factor is something that multiplies to it. So greatest common factoring, which we abbreviate as GCF, and that's what we'll probably call it from now on, GCF factoring, although it doesn't really make sense because the F stands for factoring. So it's just GCF, is used when each term has something in common. I mean, the C stands for common, so it's common factoring. And what we mean by that is everything in the polynomial has something that it can all be divided by. And so you could divide everything by that something, that common factor. So look at some of these examples. Each term of the expression, so 2x plus 6, each term can be divided by 2. So that means that 2 is the greatest common factor here. It's the largest thing we can divide both 2x and 6 by. And when you divide 2x by 2, you get x. When you divide 6 by 2, you get 3. Therefore, 2x plus 6 can be factored to 2 parentheses x plus 3. Kind of circled over that. 2 parentheses x plus 3. Did it again. And what this is saying is 2 is the factor that we're taking out, and what's left over is what's called the quotient, is the result of after the dividing. So 2 is what I can divide them by, and after I divide each thing by 2, I'm left with x plus 3 as a quotient. That's what's left over when I divide everything in here by 2. So that's a numerical factor. Everything can be divided by 2. In the second example here, x to the third plus 6x to the second minus x, notice that everything has an x. So that means everything can be divided by x. But again, it has to be everything. Like if there was a plus 4 on the end of this with no x, then we can't take out an x. It's got to be every single term in the expression can be divided by the same thing. And so everything in here can be divided by x. And so when we do that, when we divide this by x, we divide this by x, we divide this by x. And so x is what I can divide everything by. What's left over? Well, when I divide x from x to the third, remember we subtract our exponents here, we're left with x squared. When I divide it from 6x squared, it's just a 6x to the first then. And then x divided by itself, anything divided by itself is 1. So this is the answer. That's what it factors to. This expression factors to that. And what you kind of see is we did distribution in the previous chapter, is that you're kind of doing reverse distribution because I could distribute this x back in and I'd go back to where I started. Just like this 2x plus 3. If I multiply 2 times x plus 3, I get back to where I started. So I'm doing reverse distribution. I'm trying to create something that, if I were to distribute it, would bring me back to my original expression. So sometimes we see numerical GCF. Sometimes we see variable GCF. Sometimes we can take out a 2, divide everything by 2. Sometimes we can divide everything by x. In this next example, the GCF is a little complex. Let me just erase a little bit of this here. It's 2x squared y. So, look at this expression first of all. Let me actually zoom in a little bit so you can see it nice and big on your screen. Yep, that's pretty big. So right here is where I'm looking. 8x to the third y minus 6x squared y squared. So what do they have in common? Well, first of all, 8 and 6 can both be divided by 2. Not only that, they both have an x. But not only do they have an x, this one, x to the third, think of that as 3x, x times x times x. And this is x squared, x times x. So not only could I take out an x, but I could take out x squared. I could take out the smallest exponent that everything has, because this has 2 x's, this is 3 x's. So I could take out at least 2 from each of them. And then they also both have a y. This is y to the first and y to the second, so I can only take out 1. And when we divide that stuff out, what's left over? What's left over is here, 4x minus 3y. So I could divide by 2x squared y. 8 divided by 2 is where the 4 comes from. The x to the third divided by x squared is where the x comes from. And the y divided by y cancels out to be 1, but we don't write it. And then divide this by 2x squared y. 6 divided by 2 is 3. But the sign is, there's a minus sign in here that's still there. The x squareds this time, completely, cross out. That's why there's no x squared in here. And y squared divided by y is 3y. So this is what's left over when I factor this into that. All right, let's try some fresh problems where the answers aren't written out for you. So factor each of the following expressions using the GCF method. That's what this says here. But I'll stay zoomed in for you. So 5x minus 20. What can you divide them both by? Well, they don't both have x, so I can't take out x. But I can divide 5 and 20 both by 5. And then in parentheses, I write the result that I would get, or the result I do get when I divide by 5. 5x divided by 5, I'm just left with x. Negative 20 divided by 5 is negative 4. That's the answer. That's it. And again, they're very easy to check. I could just distribute this and see if I get back to where I started. Reverse distribution, that's what factoring is. How about 6x plus 9? Very similar. Again, there's no x that I could take out. This doesn't have an x, so it's just it's going to be a number. And 6 and 9 can both be divided by 3. And what's left? Well, when I divide 6x by 3, 6 divided by 3 is 2x. When I divide 9 by 3, 3. That's it. Pretty simple. Here, let me zoom out a little bit so you can see previous answers too. How about that? All right, how about this one? 2x squared minus 6x plus 8. So it's it's not always two terms. It could be as many terms. It could be a 5-term, 7-term, a 20-term expression. But if there's anything that everything can be divided by, remember, it has to be everything. Like this one, this has an x, this has an x, but this doesn't. So you cannot divide by x here. But I can divide all 3 of these numbers by 2. They're all even numbers. And so when I divide by 2, take 2 away from 2x squared, I just get the x squared. Take 2 away from negative 3x, I get negative 3x. And 2 away from 8, I get 4. Now remember, when I say away from, what I'm really saying is divided by. So 2 away from that, 2 away is negative 6 divided by 2, 8 divided by 2. Because remember, factoring is a form of division. Distribution is a form of multiplication. So if we're reversing distribution, then we're dividing. All right, how about these? These, I think this row is going to have a variable GCF here. So this first one, you see they both have x. Now this has 2 of them. This only has 1, so I can only take out 1. But I could divide everything by x. And when I take x or divide x from x squared, I get x. When I divide x from 5x, I get just 5. When this next one, again, I could divide everything by x, just x. 2x squared divided by x is 2x to the first. And negative x divided by x, the sign always stays there when I'm doing GCS, unless I take out a negative, but that's kind of rare. What happens here? I have an x here, and I'm dividing out an x. Well, anything divided by itself is always 1. So if there's 2 terms here, there's going to be 2 terms in here. If there's, 3 terms here, there's going to be 3 terms in here. You're just simplifying it by taking out a common thing you could divide them all by. Let's do this third one here. Let's see. All right, they both have x and they both have y. So I could take out x, but how many x's? I got 3 here, 2 here, so I could take out 2. Take out the smallest exponent. They both have y's. This one only has 1, so I can only take out 1. You can always write that exponent of 1. You just don't have to. So what's left over? If I take away x squared from x to the third, I have 1x left over. If I take away y to the first from y to the first, it's gone. Minus 5. X squared, take away x squared, gone. Y squared, take away y to the first, still left with 1y. That's it. Okay, just 2 more quick ones. These are examples where, this top row, what I showed you was numerical factors. Take out a numerical GCF. And then this one was taking out a variable GCF. Well, these last 2, it's just a combination. We're going to take away a numerical GCF and a variable. Sorry, I'm just trying to change the color. My pen's being a little weird. But, all right, we'll stick with blue. That's fine. Blue's writing just fine. So looking at this, first I look at the numbers. Can I divide 3 and 12? Yes. I could divide them both by 3. And then do they both have an x? Yes. This one has 2, this one only has 1, so I can take out 1x. What's left over? Well, the 3 divided by 3 is 1. Remember, you could write the 1 if you want to. You don't have to here because x squared divided by x is x. So it's going to be 1x. But if you'd rather, just write it as, it's not working now. If you'd rather just write it as x, that's fine. 1x is x. Negative 12 divided by 3 is negative 4, and the x divided by x is gone. So that's it. So let me tighten this up a little bit. There's the answer. And the last one. There we're done. We're coming up on 11 minutes, so that's a good amount. Let's see, will this change there? Now am I writing green? No, it's still blue. Oh well, that's okay. Let's see. First looking at the numbers. I got 10, negative 5, 25. I could divide all these things by 5. But not just 5. Let's see. They all have x. So I could divide by x. This has 3 of them, 2 of them, only 1, so I can only take out 1. This has a y, this has a y, but this does not have a y, so you cannot take out y. 10 divided by 5 is 2. X to the third divided by x is x squared. Y to the third divided by nothing stays y to the third. Let me remove that. Negative 5 divided by 5 is negative 1, which I can write. I'll write it. I don't have to here because there's other things. You only really have to write the 1 if it's the only thing, but because I'm going to also have x's and y's, that's where you don't have to write it. X squared divided by x is x, and then the y squared divided by nothing stays y squared. And lastly, 25 divided by 5 is 5, and the x divided by x cancels out completely, so that's it. And that's it. And then we should be able to look at this and say there's no common factors here. You know, 2, negative 1, 5, you can't divide them all by anything besides 1, but that doesn't do anything. They don't all have x, because this doesn't. They don't all have y, because this doesn't. So that is it, and that's as far as we're going to go here. So that is Unit 3, Section 1, the first section of factoring, and things are starting to get a little crazy out here on my computer, so I'll stop the video. Have a great day. See you.